You know, we do it all the time without even thinking about it. You see a video, you tap that little play button, and boom, it just works. But behind that simple little icon is this whole universe of mind-blowing engineering. Today, we're going to pull back the curtain on that complexity and really dig into the tech that makes seamless video streaming a reality.
But really, have you ever stopped to think about it? How does your phone instantly play a video that was shot on some completely different camera on the other side of the planet without making you download some giant clunky file first? Well, that buttery smooth experience is no accident. It's the result of engineers solving some seriously tough problems. So here's our roadmap for this explainer. We're going to start with why video is so tricky in the first place. Then we'll get into the magic trick, which is called transcoding. After that, we'll see how a smart, data-driven game plan is absolutely key. Then we'll watch as the actual pipeline gets built, piece by piece. And finally, we'll dive into how they managed to make it all work at a massive scale without breaking the bank. Okay, so first things first, why is this so hard anyway? I mean, sending a photo or a PDF is pretty straightforward, right? Well, video is a completely different beast. It comes with its own very unique set of headaches.
It really boils down to these 4 big challenges. Number 1, file sizes are just enormous. You can't just download the whole thing before you hit play. Nobody has that kind of patience. 2, there's no universal format. Your iPhone doesn't want to play a Windows media file, and a Windows PC might choke on a maxed-out MOV file. It's a mess. 3, you've got this thing called codecs. You can think of a codec like a specific dialect. So even if 2 videos are both .mp4 files, one might be speaking a dialect your device doesn't understand. And finally, there's bandwidth. Your internet connection can be awesome one second and terrible the next, especially if you're on the move.
So how do you solve all of that? The answer is a process called video transcoding. Honestly, the best way to think about it is as a universal translator for video. It takes any video in any weird format and converts it into a version that basically any device on any network can play perfectly.
And the real goal, the holy grail here, is to enable something called adaptive bitrate streaming, or HLS. This is the magic that stops that dreaded buffering wheel. Your video player is constantly talking to the server, saying things like, hey, my connection's a little spotty right now, send me the lower quality stream, and then, okay, we're good now, hit me with that beautiful crisp 4K. It's this constant negotiation that creates that seamless experience we all just expect.
Okay, so you know you need to transcode. But how do you actually build a system to do it without spending a fortune? Well, we're going to look at how one company, Egnyte, tackled this exact problem. And their secret weapon? They didn't guess. They let the cold, hard data make the decisions for them.
And right out of the gate, they hit this massive fork in the road. A user uploads a new video. Do you transcode it right then and there? Or do you wait until someone actually tries to watch it?
And this is where it gets really interesting, because there's a major trade-off either way. If you transcode everything the second it's uploaded, that's the asynchronous route, you're going to waste a ton of money and computing power on videos that nobody ever even watches. But if you wait to do it on the fly, when someone clicks play, well, that user is going to be staring at a loading spinner, which is a terrible experience. To avoid that delay, you'd need incredibly powerful and incredibly expensive machines.
And this is where data saved the day. They dug into their logs and had this huge aha moment. They discovered that most people don't watch videos immediately after they're uploaded. There was almost always a gap, usually a few hours, between upload and first view. That single insight was a complete game changer. It meant they had a window of time. They could go with the much cheaper asynchronous approach, and they didn't need to build some crazy expensive real-time system after all.
And the data just kept on giving. They analyzed the types of files users were uploading and found out, hey, most of these are already in the friendly MP4 format. This was awesome news. It meant they didn't have to transcode every single file. They could be surgical about it and focus their precious computing power on the real problem children, like all those .mov files coming from Apple devices. So, now that they've got this super clear, data-backed strategy, it was time to roll up their sleeves and actually build this thing. Let's take a look at how all the pieces of this transcoding machine fit together. At a high level, the whole process is a 4-step dance. Step 1, a new video gets uploaded and a message goes out to the system saying, hey, new job for you. Step 2, a transcoder grabs that message and uses this workhorse tool called FFmpeg to do the actual conversion into all the different quality levels. 3, all those new video pieces get stored somewhere safe and accessible. And finally, step 4, a special video service grabs those pieces and serves them up to your screen the moment you hit play.
So the pipeline works. That's great. But the next, and maybe even bigger challenge, is how do you make this thing run for millions of users without your cloud bill exploding? This part is all about being ruthlessly efficient.
The first big question was, build it ourselves or just pay for a service? And wow, this quote tells you everything you need to know. Their math showed that building their own system would be a staggering 90% cheaper. When you're talking about this kind of scale, a decision like that easily saves millions of dollars. Okay, so they're building it, but where do they run it? They could have used a serverless platform, which is kind of like renting a car by the minute. It's super easy, but it's not great for a long, heavy-duty job. Or they could use Kubernetes, which is more like leasing your own fleet of trucks. You get way more control over the engine and the hardware, which for a CPU-guzzling task like video transcoding is exactly what you need. So yeah, Kubernetes was the hands-down winner. But just how big should those trucks be? They actually ran a bunch of tests, and what they found was fascinating. You can't just throw more power at the problem and expect it to get faster. Look at this. Going from 2 to 4 CPUs gave them a huge speed boost, but going from 4 to 8 barely made a dent. They hit a point of diminishing returns, so they found their Goldilocks zone. 4 CPUs was the absolute sweet spot for performance and cost.
And they found another brilliant way to save money. They use something called preemptible nodes. The best analogy is flying standby on a plane. You get a massively cheaper ticket, but there's a small chance you could get bumped if they need the seat. For them, this was perfect. Since their whole system was designed to handle a job failing and just restart it automatically, getting bumped was no big deal. It was a super clever way to get computing power for pennies on the dollar.
Now, a system this big and complex doesn't just run on its own. You need to be watching it constantly. You need smart automation to keep it humming along 24/7 without needing an army of engineers.
To check this out, their system is always keeping an eye on the line of videos waiting to be processed. Think of it like the checkout line at a grocery store. When that line, that backlog, starts getting uncomfortably long,
Bam! An autoscaler kicks in and is like, hey, we need to open more registers. It automatically spins up more transcoding machines to chew through that queue. And then, just as importantly, when the line gets short again, it shuts those extra machines down. That's how you perfectly balance speed for the user with cost for the business. You only pay for what you need when you need it.
But what happens if one of those checkout lanes just freezes? A single job gets stuck. Well, they built in health checks for that. If a transcoder stops making progress or goes quiet, the system flags it as unhealthy, and then Kubernetes, the manager, just steps in, shuts down that broken lane, and opens a fresh one in its place. It's a self-healing system, which is just so cool.
and that's what you get when you put it all together. It's not just a simple converter. It's this incredibly robust, automated, cost-efficient machine that can be deployed anywhere in the world to make sure that when you hit play, the video just plays.
So they built this absolutely amazing system that solves the video challenges we have right now. But the world of video, as we know, never ever stands still. What happens when everything is live, when you can interact with the video, when every file is a massive 8K stream? How do these systems evolve to handle that? Well, that's the next great engineering puzzle to solve.